Okay, we start the event now. Yeah, I think we have 14 participants. Perhaps the numbers are expected to go down the time. Yeah. So thank you everyone for joining the August meetup. So just a quick reminder on the event etiquette itself. So please mute yourself when you're not talking. And perhaps if feel free to raise any questions. Perhaps what we can do is we can take advantage of the Zoom chat functionality to throw out any questions. I can help that. I can help to bring that attention to the speakers itself. Perhaps if there is any break during the talk or during the end of the talk itself. As always, looking for speakers. If you think you have any ideas, perhaps if you have something in mind, if you would like to brainstorm, feel free to reach out either to Steve or myself. We can brainstorm and we can deliver a content in this meetup subsequently. Yeah. So, as usual, very much thankful for Horangi and AWS for sponsoring the event tonight. So, other thing is like you can if if this is the first time for you to in this meetup, perhaps this is something which is familiar for most of the the meetup folks itself who have joined this talk earlier. Perhaps if this is the first time, you can connect to this meetup community in either ways, like either through a meetup page, you can directly reach out to your fellow community folks, or through the organizers, use the chat functionality to reach out to the organizers directly there itself. Or the most promising channel is basically Slack. It's very active. You can see a lot of communication going on, and this can be the right opportunity for you to connect to your fellow community folks and to reach out to the organizers if you would like to. So I'm sure by now most of you all aware that we have this reinvent by November, and it's about 4 days. So this is the most promising event. Perhaps if you have not attended before, make the best use of it. There are a lot of technical contents and a lot of exciting use cases which we could listen to, and this is the most promising event I have personally enjoyed myself for the last 3 years. So here is the agenda for tonight, and we have Rohit, who will be talking about the serverless and data copying pipelines. And Rohit is from India. Thanks, Rohit, for joining this meetup. And the second talk is basically from Sashi, and Sashi will be talking about S3 object lambda and the Cloudfront functions. I think both the talks are indeed interesting. So looking forward to it. And thanks, Sashi. Thanks, Rohit, for delivering the talk tonight. So without any further wait, I think I'll pass over my screen sharing to Rohit. Rohit, if you would like to share your screen.
Thanks for the introduction. Yeah.
Thanks.
Cool, guys. I'll just start the screen share. Just let me know if you guys can see my screen. You guys can see my screen, right?
Yes.
Thank you. So basically, just to introduce myself, I'm Rohit Kumar. I am currently a staff software engineer at a company called Intuit in India. Prior to this, I have served some tenure roles at Amazon and Akamai, and worked for other startups as well. My introduction with AWS started with basically Amazon, where I was responsible for the detail page team, and at that point in time, we also integrated a lot of AWS technologies into their core tech stack. Currently at Intuit, I am working as a staff software engineer for QuickBooks Online Advanced, and this team is basically responsible for maintaining a product called QuickBooks, and we completely are on AWS as of now. So with that, I'll just start the talk. So when I joined Intuit, like we had a use case where we were actually migrating the data to cloud. And any particular organization which has a lot of legacy code base, right? And they currently run on primarily on the their in-house data centers, they will have this kind of a journey where they will kind of walk and run into AWS or any public cloud for that matter, right? So when they so the walk phase will be typically starting with like you lift and shift your applications onto AWS, doing bare minimal that is required in order to move to AWS, and then exit your data centers on your on-premise data centers. Then you will have a crawl phase where you will actually start to look at your cost, look at your data models and stuff like that, which is optimized for cloud or not. And then you will have a run phase where you will start to actually integrate new features, new step, and then you will start to utilize the complete advantages of cloud. Now, when we move through any of these stages, right, you will see there will be certain challenges. You will see cost increasing drastically. You will see that as and when your whole organization starts to move to cloud, you will see governance governance will be a big issue. Like you will not be able to understand like what exactly is happening where and what policies are enforced where. And initially, when you will when a majority of our applications are going to move to AWS, your majority of the bill will come, at least for us, was coming from only 3 services. Like we were using EC2, S3, and RDS, and some of the network capabilities that were present in cloud. It basically increased with times as we were experimenting and prototyping and building new capabilities onto cloud. So these are some of the challenges that we faced while while going from the move to run phase. So there's an inherent challenge where the complexity of the systems kind of grew as and when we moved into the cloud. There was cost management and governance, right? So we started facing issues. We started running into issues like, is this the right tech stack, or are people just building things without keeping costs into mind? Then there's an aspect of security hygiene. So security is like, at the time of movement, you do some security standards, but it becomes very difficult to enforce it over time in a compliant manner with policies and set of governed stuff, so that you don't drift away from security. Then there is obviously reliability and observability engineering that comes into picture. And by reliability and observability, we mean that when we are on cloud, right, typically we have to think that things will fail. Now, how do you make sure that your applications are up and running when things are failing all apart, right? And obviously, when you're running to observability, when things starts to fail, you need to rely on your observability engineering to understand that, okay, are we able to see parts of system that are failing? And this will become overly complex with time. It will involve a myriad of system, right from because some of the data some of the data will reside on the host, some of the data will reside on different systems, some of the data will be on your lambda functions, and some of the data are even in your architecture documents. So there is not a single tool that can actually solve your observability challenges at scale when you're moving into cloud. So and this slide basically talks about, like, it is very easy to build complex systems in AWS, right? Because AWS gives us a capability of actually spinning up hosts on the fly. You get a data storage, and you get a myriad of other services that comes with AWS, like S3, and you can spin up a network in no time, right? But with this, if the applications are not thought through, it is going to lead to catastrophic failures, which will become very difficult to manage over time. And we have had these experiences firsthand. So what do we need in order to like solve this, right? So we need to build some horizontal capabilities that can be used org-wide and can be managed by some central team inside your organization, right? So we need to build security and compliance. So for that, you need to have a security policy enablement, so that people log into an AWS account through, let's say, your corp ID, rather than actually creating a different credential. You need to have asset attribution. So whenever we are using a particular EC2 machine, we need to tag them properly so that the data flows into our cost governance dashboards and stuff like that. And infosec hygiene, which generally happens, and there needs to be a continual compliance on all of these policies. And the only way in order to achieve all of this, like cost optimization, observability, and SRE functionalities, is through automation. So when you will have different applications moving on to AWS, it will be very difficult. So let's say at Intuit, we host more than 150 plus applications currently, just from my team on AWS. And it will become very difficult over time for a lead or a like a leadership team to actually monitor and have visibility into all of these applications, right? So, and the applications are not just consisting of a monolithic code base, right? It is consisting of more than one microservices. There are config repositories, and of course the infrastructure is there, which is as a code. So we have infrastructure repositories as well, right? So all of these can be only managed through proper automation rather. If we are going to delve into manual checks and balances, we are bound to fail after a particular point in time. So that brings us, when we were initially like looking at automation, right, that brought us into a mindset like, what is the right tech stack to use in AWS? Do we use serverless? Do we use containers? Do we use something else altogether, or do we use just plain EC2 machines, right? So we looked at it and we got to know that there are certain things that are common, right? So when does what fit into our use cases, right? So before that, even we looked at like what exactly is serverless. So we thought that serverless is basically a model that will basically absolve your underlying OS capabilities, and a developer currently working on serverless doesn't need to know what is the underlying OS and or what is a cluster, or what exactly does AWS spin up internally in order to handle your workload, right? And it gives proper abstractions like lambda and step functions, and OpenFaaS is some of the proprietary things that you can use in order to build serverless technologies. And then again, the containers part of it is basically comes into a picture when you are basically doing more of an enterprise sort of a development, where you need to package and install your basically the deliverable as part in an OS environment where they can be run. And ideally, like it basically has some sort of an orchestration layer on top of it. So basically, we internally use Intuit Kubernetes service. You have which is like a flavor of an EKS, and then you have Fargate, right? So these things basically help to manage your infrastructure, and this will basically be more useful to you when you are traditionally running a more of a proper workload with a microservices kind of an environment that can actually isolate your containers on a particular virtual machine, right? And finally, you have just like the virtual machine with the bare minimal virtual machines that are running on a pool of physical resources, and you might like need to bootstrap it, let's say with Python or Java or something that you are using, and this doesn't contain anything, and you might need to put a load balancer in front of it in order to manage workloads, right? So there are certain constraints that comes with these kind of things, right? So if your service doesn't persist state locally, right? By state locally means that I mean that you don't have a database per se, and you have things on your file system, right? And so before moving into cloud, you need to refactor these away if you want to leverage serverless or containers, right? And because lambda has a 512 MB tempfs storage, and that is all that you can get, and the data there might not be even encrypted, and you might need to face some other issues with security and other compliances as such. So but if you have other use cases that require some sort of a longer storage, where you need to persist some data for some interim state, you will likely need to stay on EC2 until like you can refactor it to that data which is there on your file system to be moved into some sort of a centralized storage like Elasticache or DynamoDB. And even with Elasticache and DynamoDB, you might need to clusterize those for failover and other stuff, right? And if your service can't work in isolation, right? So typically when you deploy your service, you will start basically a virtual private cloud. So you will deploy a service in a VPC, and your VPC will have basically a lot of subnets, right? So you will start with your database in a different subnet, and you will start with your application in a different subnet, so that you don't have your blast radius basically reduces. In case of a security breach, to your application, your data might still be protected, right? So if you are doing such kind of a computation, you will need to understand how pre-warming of a lambda will basically work, right? So lambda has this cold start problem. So with the cold start, like let's say if you are getting a request from a customer and you are basically starting your infrastructure, this experience for the very first lambda could be a bit problematic for a customer request, right? So there are other factors as such, right? So there are factors when we are considering this set of technologies. There are performance and cost. With data becoming more important, right? Performance becomes kind of table stakes for it, right? So if you're having a service that rapidly bursts in traffic, right, or you have like kind of variable traffic, or you have let's say a holiday traffic coming into picture, uh, a container or a serverless will have a way to react faster to variability in load. But an EC2 is constrained by the way in which an EC2 instance will bootstrap, right? So, and it will also depend on what exactly we are doing at the time of bootstrapping of EC2 instance. So if let's say at the time of bootstrapping of EC2 instance, you are connecting to a particular database, or let's say you are reading something from the file system, right? Then the bootstrapping of EC2, the auto scaling needs will take a particular time. The other option is like basically you can pre-scale to meet the expected needs, but then you are not utilizing cloud to the full benefit, right? Um, uh, the other aspect is cost. So when we say that serverless hosting basically is going to be a lot cheaper, right? If we look at economies and efficiencies of scale, right? If your instances are not like if your EC2 instances are not very underutilized, and when you move to serverless, you are most likely to gain the cost benefit. And of course, this comes at an thing that the low cost of serverless is due to this inability to share backend resources, right? So when you are doing EC2, right, and you're doing workloads on EC2, right, there are a lot of things that basically gets shared between EC2, and I'll deep dive into it, like what exactly is serverless and how exactly we have leveraged serverless technologies to come up with data pipeline solutions that into it, right? Okay, so with that, I think what the guidance here is that if you're even having an event-driven architecture, right, where a workflow or something is launched and is processed in reaction to a specific event. For example, a request is getting submitted, let's say an object is getting uploaded to SQS, or let's say something is getting uploaded to an S3 bucket. You might want to leverage serverless technologies, but that too, you might need to architect it very correctly, because each of the lambdas and everything will have, let's say, an inherent timeout of 15 minutes. So it is more or less good for workloads that finish well within that time. However, we have exploited it to go beyond that 15 minutes, and I'll talk later in this slide as to how we have achieved that. Okay, and if you have a synchronous service which process, let's say, less than 60-second REST kind of a service, let's say you have an API that obviously API DP 99 responses should be less than a second, right? So if you have, you should leverage serverless first and then containers second. And but if you have a synchronous service that require a very long-lived connections, right, that maintains connection pools to databases or something like that, you can have it via an approved container, a container mechanism with a proper scheduler on top of it, right? And finally, EC2 should only be leveraged which have a demonstrable, when you have a demonstrable reason that, okay, I cannot go beyond this. And even in EC2, you might want to look at your cost over time and then try to optimize it. With that, I'll come to a use case where we have actually, we had a use case of automating a data pipeline inside Intuit. So when we were actually when we were looking at a product, right, a product was basically having a lot of transactional data, and this kind of went into terabytes of storage, right? And we wanted to, when we were rolling out features to customer, we wanted to make sure that this feature didn't cause any sort of a latency regression from our end, right? So when we saw that this regression, how can we automate this? How can we basically left shift this kind of a problem so that we can basically look at it into our own development environments, and we can say that, okay, something is causing a latency regression. And there's a lot of literature outside, and trust me that this is a very difficult problem to solve. And we have burnt our hands quite a few times, and I have done that in various companies as well. So other than that, we wanted to understand, like, when we wanted to solve this kind of a problem, right, we wanted to understand that can we develop even a generic solution for it, or does it even require something which is very specific to our use cases, right? Then we came up with an approach that, okay, when we are running a performance test against a baseline, which generally any organization will do before releasing code to the to production, we saw that over time, right, the performance tests are basically writing to our databases, and it is polluting our data, and over time the results become skewed. And this generally is a problem with any performance testing pipeline, where developers kind of leave the test cases which are not very clean, or they don't like close resources or write data to the databases. Other than that, we also saw that the workload, right, the database size basically increases over time, and we wanted to manage the infrastructure in a way there that we see the size of the database and everything to be exactly the same as that of production, right? And obviously, when we want to test this, when we want to run the production data, we want the performance test, we want some sort of production data into our pre-prod databases. So we wanted to solve the use case of basically copying the production data into our lower environments, and then basically applying that to a myriad of use cases, right? So we saw that it can be applied to development use cases, where let's say you are looking at a prod bug where you don't have the exact data which you can use to reproduce in your pre-prod environments. So you can basically have some sort of use cases where you can take the data from production, copy it via an automated pipeline into pre-prod environments or your development environments, and then you can do a typical testing, dev testing on a particular use case, right? Then there are certain aspects of research which I'm not going to talk into more details, but you take the prod data set and you do some sort of an analysis and you normalize the data, and basically your marketing and your analytics teams rely on that data to understand more on customer behavior, right? Of course, testing is what I talked about. And then you have disaster recovery, which is again a broad topic, where you basically take your prod database and then you fail over to a different region in case of a catastrophe. Although it will have some certain implications on how big exactly you the requirement that you set. Basically, the mean time to detect and the mean time to recovery is the two parameters that we look at here in order to fail over a particular database. And then you have training, where you basically let's say you have to train a particular new set of resource. You want to give him a sandbox environment to play around with your prod database, prod product, a replica of your prod product, and he or she can see what exactly the features are there in the product and understand the product better. When we wanted to do this, we wanted to create a generic solution and an automated solution which kind of takes a production database and then copies it over to a pre-prod or to another environment. Basically, currently the solution works on the same AWS account, but we want to extend it to let's say support like taking that copy of production database and moving it across accounts as well. And we wanted a very cost effective and a scalable solution. And by scalable, I mean that it should be applicable to different kinds of RDS. Like any database, like let's say today it is supporting Postgres, and it should also support MySQL, and it should also support other sets of RDS database as well. And it should basically be a very self-reliant kind of a system, where you don't where a person basically triggers it and forgets it, and then it will internally do a self-healing sort of a thing, where if it gets a failure or an error, it will do a retry and stuff, and then finally send out an email telling that your production database is kind of copied. And this is where we launched Trafius. This is basically our open source repository, which internally was vetted by us, and we have used it for a myriad of use cases internally. So it's basically an automated restoration pipeline that works for both a clusterized database, or let's say just an instance of a database in AWS. So what we initially thought, basically we had a lot of approaches to do this, right? We basically wanted to set up, like, let's say, and just fire an AWS command on top of your database to just copy it, take a snapshot, and then wait for the snapshot to happen, and then copy that snapshot to another AWS account and then restore it. But then we face that when we are doing this, we face a lot of other challenges, right? That particular downsized account might not be having the same set of security policies, or let's say the network, like if we have the production, if we want a database in a particular VPC or something like that, we want the network to be exactly replicated in a pre-prod environment as well, right? And we want other aspects of it. Other way was basically doing it also via a SQL dump, But when we thought that the database size is basically too huge, right? The SQL dump takes a lot of time, and we want it to be like pretty fast so that people can actually run. We don't want performance tests to like, or any other use cases that we are doing to take a lot of time, like let's say days or something like that. And when we developed it using snapshots, we saw that the time reduced by 4x. And and the more and more human intervention happened in this process, the older process, the more and more erroneous and cumbersome it became. So we wanted to automate this completely with a very standardized interface, and so that anybody can do it, right? So we started with a step function, and we had like a concept to realization where is a root state, where the step function actually branched from into two. Let's say if you have an RDS cluster, or if you have just a plain RDS instance, it will go ahead and it will basically do the restoration for you. Now I'll just show you guys just an AWS account where we have actually ran it, so that you guys can understand in more detail. So if you guys look at this, right, this is basically the open source repository that I was talking about. And my colleague, I think probably she's on the call, has developed this repository and is currently the maintainer of it. This basically has a proper README where you want, if you want to go ahead and do a restoration of your RDS database, and it has a simple setup file, which basically asks you for all the data that you need in order to set this up. So once, if you look at it, right, if we run the setup file, it will basically start asking like, is there an S3 bucket that you want to connect to, enter the region where you want to run this, and it internally will use SAM, which I think most of you guys might be familiar with, and it is written in Python, and it will start and it will deploy a state machine onto your AWS account. So it and the state machine basically, and it's seamless, right? You will just do that setup py, and it will take a set of inputs from you, and it will deploy the state machine onto the cloud. And the state machine will come with every other lambda functions that I was talking about earlier, right? If you need to do take a snapshot, and if you need to restore the data from the particular snapshot, and if there is a failure, if it will do a retry internally as well. And post that,
Rohit, do you mind to show the statement machine one?
Yeah. So this basically will start the cloud formation, and it will create a state machine. Now, once you have the state machine running, right? So this is one of the execution that I just ran just to show for a demo. So this is the state machine that it will install, put in your basically an AWS account, and it will internally handle, or if your lambda is behind, if your database is behind a VPC, it will create the lambdas behind a VPC so that it doesn't have any connectivity issues. And once you look at the state machine, you can just basically start the state machine with an execution and give just two parameters, and the two parameters are basically these are the two parameters. Right, and it will basically say your identifier name, which is basically your database name, right? So if you look at my RDS here, right, it will just have the database that I have created, right? So if I have database -1, I'll just give here database -1. Just let me go to the step function again. Yeah, I'll just give you a database -1. And I will give the task name. If it is, it's mentioned in the docs whether you want to create a snapshot or you just want to restore from a snapshot. If you want to restore from the snapshot, it will take the latest snapshot in your account and it will restore it. And you will basically give, let's say I give create snapshot as a task name, and you will say whether you have just a cluster of a database or you just have a normal database, and you just trigger this execution. So if you see, there's currently an execution that is happening, and it might have failed for some other reasons. And I want to show that in case of a failure, we auto roll back so that your databases are currently in that older state, and we send out an email and everything. And that is all configurable as part of the state machine. And the README has the exact data on how to do that. So, we basically, as part of this, we are executing everything as part of Lambda. So it is all serverless. And when we did that, one of the things that we faced a challenge is like when you restore a data from like even if you're restoring a data from a snapshot, right? If your database size grows, so when we are having a database of let's say 1 terabytes or something like that, right? If your database size grows, we are ultimately using a lambda, so it will kind of hit that 15-minute timeout of that lambda. So what we are doing is internally we are actually using waiters. And as part of our code base, we have configured the waiters. So once we look at the lambda execution context internally, and we see that whether the lambda is going to hit that 15-minute timeout. And if it is going to hit that 15-minute timeout, we check whether the database has been restored or not. If it is not restored, we basically throw a retryable exception, and that lambda is retried and the timer is basically reset. And that is how we basically restore a very large amount of database in a very cost-effective manner. And the cost is like the cost for this comes very it's like hardly very cheap, like buying a cappuccino outside. And the other aspect of it is that if your data is very small, right, this will just run in one shot without even retrying the lambda, so the cost further reduces. So that is what I wanted to show you guys, and I wanted you guys to give some inputs on how exactly you think this is, and please do use this repository, and if you guys have a similar use case internally, and do let us know if you have any feedback on this. That's all I had. Like, thanks for listening.
So Rohit, quick question. So this one is only for the RDS. You have done this one, is it Trophius? Yeah,
so the Trophius is currently done for RDS, and it is like for any sorts of RDS. Like if you have a MySQL or an Aurora Postgres, or let's say even the other forms of RDS, right? So that will serve for all of that. We are currently on the path of exploring the path of doing it for NoSQL databases as well. So we just want to like fit it into the framework so that it can happen seamlessly.
Okay, so it's a bit it's pretty much interesting because recently we have seen the products of you have heard of Portworx and Cohesity and all those guys, right? Yeah. So those guys do the same thing, but they do it at the persistent volume layer level, like EBS volume and all.
And so the other thing is like if you what I have like looked into is like if you look at a database snapshot, right? Well, how AWS basically internally takes a snapshot is it looks at the database log, right? And does take an incremental snapshot. So let's say if you have taken a snapshot at point X, and if you take a snapshot at point X plus 2, it will just do the incremental plus 2 delta, and that makes it like pretty fast, right? If you look at other things like by EBS, if you mean like the EBS volume itself, right? Yeah, if you do via that approaches, I'm not sure like what kind of a privileges you might need. So when Trophius operates, right, it takes the IAM roles that it internally creates, and it operates on the RDS in the same VPC. But if you might want to hook into database logs as such, it might need some root level privileges is what I feel, which might become a bit trickier to implement. Yeah. Does that answer your question, Sashi? Or?
Yeah, that answers my question. So usually, actually, like we are looking for EK mostly on the container perspective. So for EKS and all, we have recently adopted for the Portworx, but this solution is open source and it looks pretty much interesting from the RDS perspective. So I can download, I can just clone the repository and use it, right?
Yeah, it has a README and it has everything, and we have even a Discord channel set up. So if you guys face any issues, then just ping me over the Discord channel. I'll be able to get you some help.
Okay.
Thanks, Rohit, for the wonderful sharing. Very, very thoughtful, and I personally enjoyed this talk. Do you guys have any questions for Rohit? No. Okay. Probably, I think Rohit can perhaps, if you would like to, you can stay in this meetup. Perhaps if you have any questions at the end of the talk itself, we can have that answer. Probably, Sashi, you want to take over the screen?
Yeah. So mine will not be that much interesting as Rohit. So because yesterday only I have taken the slot from Steve. Okay, so
Yeah, go ahead.
so basically, like recently, we have seen in the month of March 2021, they have launched AWS have launched the S3 object with Lambda, right? So before coming to that, myself Sashi, and I'm working as a solution architect in NCS Singapore. I have around like 11 years of experience, and most of the projects what I deal with is all the government agencies within Singapore, like IRAS, MOM, and MOH and LD and all those guys. So I work as a pre-sale solution architect, wherein I liaise with number of government agencies, like dealing with the solution architecture team from AWS and getting the solution out from AWS and meeting the customer, meeting the customer like IRAS or some government agencies, right? And understanding their problem and making sure like whether the solution given by AWS or Azure or GCP is best retrofitted with the customer from the customer perspective. And once it is done, I'll liaise with my delivery team. I have a delivery team back in NCS and back in Pune, NCS Singapore and back in Pune. So I will work with the respective teams to get the things done for the government bodies over in Singapore. I mostly deal with GCC, which is the government commercial cloud within Singapore, and some portion of the commercial aspect of things as well. So commercial aspect of things, I mostly deal with Keppel and some portions of DBS, because I have worked in DBS for almost like 8 years. So that is the reason I deal some parts of DBS projects as well. Okay, so that is on a high level what I do, my career backdrop now. So coming to this S3 object with Lambda, right? So there is some confidential government body which is using whole of serverless architectures. So
sorry, breaking you. Can you go into the presentation mode, or perhaps you want to zoom in a bit more?
Yeah.
All right, much better. Yeah.
Okay. So as we know, like AWS has recently introduced this S3 object lambdas and all, right? So we all know like this lambdas sit behind an S3 access point, and which can transparently mutate the objects, whatever mutate the get requests as they retrieve from the S3 bucket, right? So I had an government body who is entirely they have implemented serverless architecture, wherein the users access and structures are access related information and the asset related information are present in the DynamoDB, and the actual assets are present in the S3 bucket. So as we all know, like as part of the common security measure, we have stored the assets in the private bucket, and they have and where they can't be accessed by unauthorized users or bots or any other malicious guys. And then we used to generate pre-signed URLs. So if I go to the next slide, right? So we used to generate the okay. And we used to generate the pre-signed URLs for the users with a valid session token or temporary token. So life is pretty much good. And when a user signs in and request a particular asset, they used to call an API from the front end, and they used to get some base. From the front end, and a Lambda used to get triggered to get the basic info and whether the authentication is successful and everything from the Dynamo by validating the user's access and everything from the DynamoDB. So we used to orchestrate the set of lambdas by using the state machine again with parallel states and all, by redacting and enriching the lambda state and enriching the assets with the assets taken out from the S3 bucket, and all those things we used to do. But we had our functions used to respond in few milliseconds, and over the period of time, it used to take like hundreds of milliseconds response to the end users. So wherein at the time we thought of rephrasing, re-architecting the entire solution by further breaking down the lambdas. But at the time we saw that we saw this as 3 object with lambdas. So wherein we have adapted the solution of S3 object with lambdas, and we have redesigned this architecture. So the assets, so the asset content is fetched directly from the S3, while all the assets are being transformed and redacted and enriched by using the signed URLs, by using the signed URLs and S3 access points in the object lambda access points. So once a specific user authenticates, right? So what happens is a signed URL will be generated, and the object can be accessed via the object lambda access point. So the use cases, what we have seen, right? The use cases, what we have done over the period of time in this project is we have done the audit related information like PIE information, access control, and all. So consider there are two different users. One user is pretty much on the campaigning side, and one user is pretty much on the analytical side. So campaigning side might require some sort of an enriched data, and analytical side might require some sort of an only aggregated data. And there is one more user who is pretty much interested in the audit related stuff. Like a particular user is what sort of information, what sort of aggregated information or sensitive information he wants, like the audit related user and all. So we used to have 3 different access points on top of the S3 object lambda access points. And we used to control all the PIE information for the analytical user. We used to not to give any sort of FIN number or passport number or any such sort of sensitive information. We not used to give to the analytical user, because only the aggregated information is required. And for the for other users, wherein data redaction also we used to do. So in the sense like only specific set of data has to be given. Consider I have a CSV file. In the CSV file, I have around like 100 columns. Out of 100 columns, for a specific upstream or a downstream or a specific user from the front end, he should access only like limited set of fields, because he is from a risk department or an finance department, wherein only the financial figures has to be catered for that particular source system, for example. So then in that case, out of this 100 columns, we used to give only 50 columns, wherein we have written Python, in some cases Python, in some cases Node.js in the lambdas. So all this access related information, like PIE information and data redaction, all these things we used to control from the S3 object with lambda, and compression and decompression also. So there are some files where used to be on the S3 bucket whenever a request of get is being happening, right? So then immediately the compression and decompression used compression or if it is not accessed at a particular point of time, the CloudWatch event will trigger an alert to the at a particular point of time, the CloudWatch alert will trigger the lambda, which will again compress the file during the night time and all. And the image resizing also we have done, which is internally for the LTA guys, for the Land Transport Authority in Singapore, right? So we have used image resizing, wherein whatever the speed, wherever the speed control is, I mean, a particular user is going out of this greater than 90 kilometers, something like that, right? And image will be taken out and given to us, right? So all these things resizing according to the devices the LT authority is accessing. We have done that, the image resizing and all. And on the fly caller specific requirements. This is one of my interesting one, in the sense like this is for DBS we have done. So for DBS, as we all know, like bank will be having a wide range of source systems. So the wide range of source systems, what we have done is a single source, like consider a source of Murex, for example. So for Murex source system, they will the same file will be sent across to 10 different upstreams, 10 different upstreams or 10 different downstreams. So then in that case, 10 different copies of 10 different copies of the file has to be transformed and given to the respective downstream, wherein the compute capacity is being wasted and the storage capacity is being wasted, and all these things is being wasted out, and ultimately like it is spiking up the bill. So what we have done is so for whatever the files that are below 200 MB, right? 200 MB, we have created this S3 object with Lambda. So what does this do is on the fly, it will convert based on the user specific downstream requirement. It will convert the file and give the necessary output to the respective downstream. And the next one is the conversion across data formats. So in the sense like I have a PDF file, I want to convert into Word document, all those things. We have used the AWS, again, S3 object with Lambda we have used, and we have converted by using Python libraries and all, we have converted data file formats across different file formats and all, and implementing the custom authorization rules to access the data, in the sense like we have used in the slide itself, it's there, right? So when a Lambda is being accessed, we used to take the necessary authorization rules of a particular user and a particular user from the DynamoDB, and enforce the respective rules when it's being accessed by a particular user. The example which I've given, like analytical and campaigning team and the audit team, right? So all this information we used to store in the DynamoDB and retrieve it and enforce the authorization rules when it's being accessed by the S3 object with Lambda. Presence URL generation is pretty much straightforward. So when a particular object is being when a particular get operation is performed on the S3 bucket, so then what we used to do is like we used to generate presend URLs, wherein once the presend URL is generated, that particular user is given a temporary session token and all the stuff, right? At that particular period of time, he can be able to access the data. So through S3 object with Lambda. So what are the best practices and what are the defaults, what we have observed so far during productionizing all this S3 object with Lambdas and supporting these customers, right? It supports only GET requests, and 1,000 object access Lambda access points is what can be enforced at region or account level. And what we have observed is 60 seconds stream is what we have observed for a complete response to the caller. So you can ask me, I mean, we have this problem of consider I have a file of 500 MB or one gig, for example. So I want to do some sort of an enrichment or redaction or PA access control, right? So as Lambda is having the 15-minute whatever 15-minute threshold limit is there, right? So what we have done is we have used the range and part number functionality in S3. So what basically this does is consider I have a 1 gig file. In 1 gig file, I would split it up by using the multi-part download. So by using the multi-part download, I'll split it up into 100 MB, and I'll stream all the 10 parts at a single time by opening up 10 concurrent sessions, 10 concurrent get sessions from S3, and the Lambda can scale up to 1,000, right? At account level, we have increased it. Until 5,000. So by using this range and part get headers, right? So we have split it up. By using the Python code, we have split a particular file which is greater than 500 MB. We used to split it up into multiples of 50 some cases and 100 some cases, based on the number of columns a particular file is having. So we used to split it up, and we used to send it to the Lambda and then stream it to the end user. and then access by the authenticated users, which I've already covered. And when we are using this Lambda execution role for this S3 object with Lambda, right, we should make sure least privileges is given. The reason behind this one is, consider you have an file which is already encrypted. So this one we have faced in production environment. So what happens is when a particular file is encrypted and we're using S3 object with Lambda. So KMS will talk with the Lambda execution Lambda, and the Lambda execution rule is having necessary privileges to encrypt and decrypt the necessary file from S3. But what happens is in the AWS environment, this necessary decryption and everything will be happening. And as we had a customer who says like, I don't want any traffic to be going to the normal internet. So as S3 is an internet-based service, right? So we have again added one more hop of adding the VPC endpoint and all those things to the customer. Wherein what happened is then ultimately what happened is that customer told in the AWS environment, the file whatever I am sending is going, and because the decryption is happening at the Lambda end, right? So what he has told is like, I want again this one to be placed in the VPC and all those things. So when we are dealing with the sensitive customers, right, like IRAS and all those guys, right? So we have to make. We had an extra caution of making sure like the respective data is present in the highly secure area within the GCC. Okay, so where should I use it? So where I have many readers who are interested in small variations of the same data, same object file. So then S3 object Lambda might be useful, will be useful, and highly dynamic data. Highly dynamic data by the time where you can make enough copies that there will be already old in the sense like consider I have a downstream where it is continuously streaming data. By the time I make a copy of it, the data is already old enough. The data is already old. The latest data is already arrived. So in this case, like where the data is highly dynamic, we can go for the S3 object with Lambda. And infrequent need to generate the different file formats like ebook conversion to PDF and PDF to XML and all the stuff. And stripping the PII information from the audit logs. In the audit logs, taking out the employee ID or employee name or passport number on all those things, wherein the amount of data which you need to read, and process it, and processing it is significantly low when compared to the amount of data you need to write. So the read of the data should be higher and the write of the data should be lower. And where I should not use it, as this is not at all a database. So this is not a small scale database replacement as well, and it cannot replace Athena also, because Athena is having Athena can give a much more nicer interface compared to this one. And high pixel image resizing and all those things we should not use, and lower read cardinality also we should not use, and long lifetime TTL also we should not use. So this is what on the S3 object with Lambda. I have prepared one demo for this one, but sadly my ECR cluster, my ECR repo is getting timeout exception. My ECR repo is getting timeout exception. I don't know. The Lambda, whatever I have wrote is on the container image, but it is going on timeout exception. I've given all the necessary things correctly, but I don't know what has gone wrong on this one. So let me go to the next topic, which is any questions on this one?
Sashi, I don't see any questions in the chat, so feel free to proceed. Yeah.
Okay. Okay, so next one is the Cloudfront functions. And so this one was also recently launched, probably I think in May or April or May it has been launched. So this one is also adapted by DBS again. So as DBS is having a number of branches, more in DBS, right? Like in India, Hong Kong, Taiwan, and all those countries, right? And the home page of DBS is same. So I'm taking the example of DBS as it is having as a spawned across multiple countries across the globe, right? So usually for the Cloudfront functions, right? For the Cloudfront functions, the basic difference between the Cloudfront functions and the lambda at edges, the Cloudfront functions can support only JavaScript, whereas lambda can support Node.js and Python. The reason why we can go for the Cloudfront functions is it is basically deployed in the edge locations, whereas the lambda at edge we can deploy only at the regional edge caches. Okay, let me give you an example on this one. So all the DBS static web pages, right, like the home page and login page and all those stuff, right? So they are trying to convert it into native languages of the respective country or state within that country. So what these DBS guys have done is they have used transcribe, translate, poly, and all those things they have used. AWS transcribe, translate, poly, and all those things they have used, and they have converted the home pages into their respective native languages. So this is still in development phase. This is not yet released into production. So consider a German guy is accessing a DBS website. So at the initial point of time, we have not converted into German language. So what we have done is, whenever there is any request coming out from the from Germany IP addresses, by using the Cloudfront viewer country policy, we have defined a policy called as Cloudfront viewer country policy, wherein we can get to know like from which country the respective traffic is getting originated. So once we see consider, for example, a German guy is accessing DBS website, so then immediately we used to trigger a lambda function, which will translate basically from English to German, and put the static web page in the S3 bucket, which will be accessed by the Cloudfront edge location. So how can we do that? How we have done this? I'll show a short demo on this one, which is a pretty basic one. So this is what we have done on the execution location. And what triggers does Cloudfront function support is only viewer request and viewer response. The maximum execution time is only 1 millisecond, and it is it's pretty much what we can say is like whatever the static assets which we are accessing, right? It will save a lot of time with respect to any sort of translate sort of stuff, right? It will save pretty much good amount of time with respect to the maximum execution time. And the max memory is only 2 MB, whereas in lambda attach is 128 and 10 GB accordingly. And total package size for the JavaScript is only 10 KB. Network access no, file system access no, whereas lambda attach we have the network access and all. Okay, so, let me quickly show you the demo. Okay, so this is the Cloudfront distribution just for this meetup I have created. So if you see the behaviors, right? If you see this behavior, I have created by using Cloudfront viewer country policy, so that I can get to know from which country the respective traffic is coming out, and the Cloudfront function name is training session I have kept. Okay, so let me take out I think I have already taken. Okay, so let me. This is a website where it will call the respective URL from that country of origin. So if you see the URL, right? So this is the Cloudfront distribution name, and this is the text. Sorry, this is the text file what I have placed. So if I copy the same thing, right? If I copy the same thing and call from Singapore. Call from Singapore, I'm getting good evening. So if I'm querying the same thing from France country, right? I'll be getting in. I don't know how to speak France and all, but it is saying good evening from France. If I say same thing from Italy, right? It's saying in Italian. So basically, like even if you are calling the same URL, what does the Cloudfront function will do is it will go to the respective static asset and call the necessary S3 bucket from the S3 bucket, which static asset it has to show to the user. If I go to the function, right? So it's a very small thing wherein I'm calling Dutch, Italian, and France. I've taken only 3 things, and it's a pretty much small code. I can send across. I have a Git small repo for this one. I can provide that link. It's a pretty much small thing. And what are the other things? What we can do is we can whatever the login mechanism will be there, right? Like just a moment. So all the static, server side logging will be there, right? Authentication will be there, right? We can make use of server side authentication also with the Cloudfront functions. That's all. Any questions on the Cloudfront functions?
Sashi, maybe I have a question. So, if I understand correctly, you're just mentioning like maximum execution time is less than millisecond, 1
Yeah.
millisecond.
Yeah.
So, isn't it something which is meaningfully possible with by having the maximum execution time by less than 1 millisecond? Even for the lambda function to come up, it can be an easily.
Here we are not using any lambda function and all. Here, here it is on at the where the edge location will be there, right? There itself, some compute capacity will be given to us, which is totally deprecated. So the maximum execution time what AWS allows is only 1 millisecond. So even this code, whatever it's there, right? It is already in memory. So once we execute it, once we process the request, right, it will be executing at the Cloudfront edge location itself. So there is no lambda involved in all of this.
Okay. Interesting.
So we have, I'm using a third-party site over here, right? So it has to, it is adding some extra hops to go to the Cloudfront. But if we are directly accessing, right, it will be much more faster.
Right. Yeah. Yeah, that's fine. Yeah. Yeah. So Sashi, are you done or?
Yeah, I'm done.
I see. Okay. Maybe another question is like, most of the times this Cloudfront functions are expected to go as a complementary factor with Lambda at the edge, right? So what are the use cases you would say, which can take advantage of this Cloudfront functions along with the Lambda at the edge? And what do you see as a general recommendation, when it comes to designing the Cloudfront function along with the Lambda at the edge itself?
Okay, for the Cloudfront function, so far what we have used, right? Only for the static assets what we have used, wherein dynamic translation can be performed with the help of translate and all. So AWS Lambda will be triggered, and Lambda will translate, and then once it is translated, right, whatever the URL which I have shown doc.txt, right, it will generate an static file .html or HTML or whatever it might be. So Lambda will be generating the HTML file of the static asset. Once it is generated, it will place in the S3 bucket, and the respective things, whenever it is accessed from the respective location, right? Like Italy or France or whatever. So this is what the use case, what we have done for the DBA static web page.
Okay. So does the Cloudfront function have to be comprehensive on its own without relying on an external dependency, or it can still be possible?
Can you repeat again, Badri?
Does it a requirement for the Cloudfront function to be comprehensive on its own, or can it also rely on the external dependencies, say making a network call to?
No, it cannot. It cannot make any calls.
Okay, I see.
It should be comprehensive. That's all.
Fair enough. Okay, noted.
Because whatever the execution time AWS has given, right, it's pretty low.
Indeed.
1 millisecond is.
Indeed. Yeah. It's too low. Yeah. So any questions for Sashi?
See, the only difference what we get is we are running the code. We are running the code at edge location itself. We don't have to come to the regional edge. We are not coming to the regional edge because only 18 regional edge caches are there. Wherein if you go to the edge location, there are around like 218 or something like that. So all this sort of cache related manipulations or URL rerating. Yeah, URL rerating is also one of the best examples. Where we have done it for IHIS, Integrated Health Information Systems, which is under MOH, right? So URL rerating also within Singapore we have done. So this URL rerating and remapping we have used for Cloudfront functions, wherein it's pretty much straightforward, right? So for this URL, push this URL, which is redirecting, which hardly takes time, which is already present in the edge location itself. And one more use case, what we have done for, again, IHIS only, the header manipulation also we have done. So consider a particular request is coming from Syncang, for example. So then in that case, we are keeping some sort of an headers in the Cloudfront functions itself, wherein we get to know like from which area we are getting the respective traffic.
Interesting. Yeah. So perhaps if there is no further questions for Sashi, then again, I would like to thank again Sashi and Rohit for delivering the talk tonight, and perhaps that concludes the meetup tonight. So feel free to stay around, to catch up, and yeah, thank you everyone.
Thank you.
Stay with you.